afternoon and welcome again back at the European Industry and Energy Summit 2021. You haven't met me yet, I'm David van Baarle from Industry Links. I will be at the table next to answer your questions at home, but first it is my pretty task to introduce you to two Martijns as we say in Holland, Martijn Hinderdaal and Martijn Glas of Stork. Stork is a technical company in the Netherlands which have a lot of good examples of how we can decarbonize the industry with the technology you already have, and we can do it fast, if I have to believe Martijn. So the stage is yours, and please take us with you to decarbonize the industry.
Okay, thank you, David. Well, here we are. So this is Martijn Glas.
Martijn Hinderdaal.
And going to our first slide here. First, we'd like to just look at it from an owner's perspective. And we believe that it's no secret that all of you out there who are an owner with an existing asset are all facing a big challenge to drive down those operational costs. And if that's not enough, you've got to drive down that carbon footprint. Does it end there? No. I think all of you are feeling regulations. It could be local regulations, could be national, international regulations that are really, pushing down you, pushing you left, pushing you right. Does it end there? No. You're also being forced to keep production up, to cater to the rising demand of goods, products around the world. So there's very little time actually to go for a big revamp and make everything green. Production is everything. And yet, while the production is very important, there's very small money even to do something with. And this could be a historical frugality, it could be investors saying you can't invest, it could be we are putting all our money into research, into new green technologies, but the end result is the same. A very small bag of money for CapEx changes. And does it end there? No. All existing facilities out there, they all struggle with that same thing, an existing footprint. So even if you have the money, you can't just change anything you want. Now, fortunately, these aren't necessarily mutually exclusive goals. And in this presentation today, we are going to just share a few of these examples to show that this isn't the case. That you can really achieve all of these in existing facilities. Now, where are these opportunities? Well, there's several distinct levels. First of all, there's the equipment level. This is a logical place to start. You start looking at your big energy users, and you can maybe reduce the friction, you can change the way you operate it, you can make some small modifications to it. True. But the bigger gains typically come when you look at it from a system point of view. So this could be an air system, a steam system. This is typically where things have happened and there's an opportunity to optimize it. We'll certainly be getting back to these systems. Does it end there? I guess you can see the white real estate there. No, of course it doesn't. At the facility level, there's also opportunity. There are heat sinks and sources where you can exchange heat, or you can make use of some calorific value that's still in those waste streams. Produce steam and use it elsewhere in your facility. And does it end there? No. More and more, we notice, of course, that there are facilities in industrial dense zones, and the heat sinks and sources could be with your neighbor. And those are, again, opportunities you more and more need to capitalize on it. And it might seem logical, but we see every single day, we see clients not capitalizing on these things. Does it end there? Nope. There's, of course, still management. Technical folks can come up with 101 fantastic ideas on how to carbonize an existing facility, but management needs to be there. Management needs to buy in. Management needs to make choices. Management needs to come up with business cases, validate them, and help with the implementation. And those familiar with ISO 55000 definitely will recognize this, the equipment, the system, and the management. They have to be in balance together, and then it will work. So what are we going to do today? We are, first this one. Where do these opportunities come from actually? Because, it's not like these engineers who developed this facility did a bad job. And that we can come in and be a lot smarter than they were, and all of a sudden, manage to make things more efficient. The reason that these opportunities exist is simply because of plant evolution. So this is all about ongoing expansion through the years. As companies are successful, they expand. And maybe there could be just more products. It could also be different products that they all of a sudden need to or can produce for the market. It could also be changing technologies. And maybe a greener technology has been implemented, giving you wins on one end, but also some opportunities or some negative things that can be taken away in a different way. And also multi-site opportunities. Some have already reached out to their neighbor facilities, and that adds a certain degree of complexity. And when that's the case, that's when you see inefficiencies creep in and add up. And those are the opportunities. And sometimes if you're too close to the situation, you don't really recognize, but those opportunities are there. So what are we going to do? We are going to basically go through a situation, paint the situation for you. We're then going to show which solution we implemented. We're going to talk about the benefits, and we're going to do this 10 times. And at the end, we're going to have a little recap. Now, I've been talking about we for a few times, sentences here already, and just a little we. We are Martijn and Martijn here, we're from Stork. And for those not familiar with us, we're a multinational operation and maintenance services company that works across multiple industries. We started over 150 years ago, and we were very much part of the energy transition back then, in the 1800s. And now, we're very much part of the energy transition that's going on right now, helping provide new technologies and low-cost operation and maintenance services to these upcoming wind, solar, nuclear, hydrogen, and other renewable sources. But we also, on the other side of this picture here, there are all these existing facilities. And Stork has tens to hundreds of people at site every single day. And that provides us with a great opportunity to basically help decarbonize these facilities. We've been doing this, and we continue to do this, and that's basically where we get these examples that we'll be showing you today, of the examples that we're doing in the field at these existing facilities. So without further ado, I am now going to start with the first example, and this is related to air compressors. So this could be the glass, the food, the steel industry, lots of industries that use a lot of air. And what we see, kind of what we were mentioning already, there was a facility in this case, and they expanded, and they started off with two, Syntec air compressors. Business went well, procurement went out, got the best offer from, let me see, this was another Syntec and a Compare. Business went well, and again they expanded, this time Atlas Copco was added. But here comes the interesting thing, is that all of a sudden you notice that all these 5 air compressors are working on the same system with their own controls, and all of them are reacting on, say, an increase of the air pressure, air demand. And they all start to rev up. And when there's no demand, all of them go down, sometimes way below their normal operating limits. So they're all actually running their own races. And there was even a user that took up 30% of the air. So when this one came online, all of them were trying to cater to that capacity, and then they started to react on the capacity increase, but also on each other. There were overshoots, undershoots, and quite often the plant would even shut down, with all the half products, waste being created there. So this was absolutely not optimal situation. And the client reached out to several companies, but they came to us, and what we subsequently did was we designed a custom-made master controller. So a controller that really stands above the other control systems, communicates with all the different compressors out there, and also communicates with the production system. So therefore it could anticipate the increase in air demand, and then simply make a decision. Which compressor is best able to cater to this demand? And it could be 1, 2, 3, 4, could be all 5. And it also was linked to the client DCS, and this allowed us to also, for maintenance purposes, which main reason we're at site there, is to shut one down safely, knowing that operation would continue in a smooth way, do the maintenance, bring it online, and basically continue the other 4. And the benefits, what we saw, we've done this at multiple sites. I mean, and of course, every plant is slightly different. That's a theme that will be coming up more and more in this presentation. But you know, the smooth operating plant all of a sudden can have energy savings up to 16%, without really touching any of the equipment, only the control systems. So a small investment, big impact that could really help decarbonize it, both from energy point of view, but also the half waste products that are being created as the plant went down. So this is just one example. Now I'd like to give the word to the other Martijn. The floor is yours.
Yes, thank you. Well, I will take you through just a glimpse of the many examples that we can deliver and have delivered on decarbonizing existing assets. And the first one I'd like to show is about condensers. Now, people who operate steam turbines, condensing steam turbines, they know that the steam turbine performance depends heavily on the pressure, or actually the vacuum, that the condenser is able to deliver. The pressure in the condenser consists of a combination of steam pressure and air pressure. Now, one issue that you may have, which is especially important when you have air-cooled condensers, they tend to start to leak after some time. And these leaks, they may be hard to repair. And then one way out may be that you consider increasing the capacity of your air evacuation compressor. Now, we have done this at one turbine where we modified the gear ratio of the gearbox that drove the air evacuation compressor. We increased the capacity and that significantly drove down the condenser back pressure. A different example is, if you have a water-cooled condenser, is that you may want to increase the amount of cooling water flowing through the condenser. This can be a costly event, because if you think of that, you may also think of buying new pumps. But us, Stork, being a pump OEM, we did a project where we actually only modified the impeller of the existing cooling water pumps. This led to higher efficiency, higher capacity, and therefore the possibility to increase the cooling water flow with only minor modifications to the total set of equipment. Now, the last option that you can do is retube the existing condenser. Many condensers are still equipped with copper alloy tubes. You can exchange these with, for example, titanium tubes. With titanium tubes, you go to thinner wall thicknesses. The thinner wall thicknesses allow for more cooling water flow, and also the alloy is suitable for allowing slightly higher cooling water flows, cooling water velocities. This in turn improves the heat transfer rate and also allows for better cleaning. So these three measures combined will all increase your turbine performance, and well, actually with only one of the three measures we have seen an increase in turbine performance of about 10%. So this is 10% more power that you gain without using any additional fuel. The next example, deaerator. We are a market leader in designing and producing deaerators. On many of our competitors, we see deaerators which are a tray type deaerator or cascade type, if you like, and these tend to have quite high steam losses. You can see two pictures here. On the left you see a conventional tray type deaerator, which we have retrofitted to a spray type deaerator. The advantage of this is that you can keep the existing pressure vessel, which makes up the majority of the cost of a deaerator. Piping will also stay roughly similar to what it was. But as you can see from the steam plume, is that there's a dramatic decrease in the amount of steam vented. This has a number of benefits. So again, with the sprayer condensing much of the steam contained in the air that you would otherwise vent, there's a really big reduction, approximately 80% of how much steam you vent unwanted. Another advantage is that our deaerator architecture works so well that you don't need those oxygen scavengers. These combined lead to two advantages. One advantage is that you don't need to use oxygen scavengers anymore. Well, on a big site, we regularly see that the costs involved are approximately 75k euros per year. But the big one is, the big fish here is, of course, the reduction in steam loss, which is usually multiple 100Ks per year that you save. Next example. I call it heat sharing. It is often also mentioned as district heating. Waste incinerators. We do a lot of waste business in waste incineration. Generally, a conventional waste incinerator designed for producing electricity only converts about 25, maybe 30% of the energy into electricity, and all of the other heat is rejected, partly through the stack, partly through the air or water-cooled condenser. But also, with these installations often being situated in industrial areas, you often have clients nearby that want steam, and often they usually produce it their own using fossil means. So again, in this case, we had a neighboring chemical site that requires steam and used fossil fuel to generate the steam. And you can bring the two together. Now, in this case, we built a steam line of approximately a kilometer to bring high pressure steam from the waste incinerator and use it to generate slightly lower pressure steam on the chemical side. And in this case, there were different chemical water treatment programs that that made it impossible to directly export the steam from the waste incinerator to the chemical side. And to keep the both of them apart, we used a steam-steam heat exchanger. So this works really well. This is approximately a 100 megawatt installation, and the benefits are quite clear. There's of course a very big reduction in consumption of natural gas. There's a very, very big increase in the efficiency of the waste incinerator, as mentioned. The conventional waste incineration plant converts about 25% to 30% maybe of its energy to electricity. And when you export all of the heat, you go to an efficiency of about 90%. Last advantage, equally important, especially on the chemical side where it's absolutely forbidden to trip the steam grid, you get a more redundant steam supply for your steam system.
Maybe just one other example I personally like. I mean, this is one was reviewed before and how do you say, but there's also, when you think about neighbors, it's not just industrial facilities. I believe we also helped heat a swimming pool in the neighborhood for Avico.
That is under discussion,
yeah.
But it's just, yeah, it works really well, you know.
The big thing is, think about your neighbors in the bigger scheme of things. It could be a greenhouse, it could be a swimming pool, there could be all kinds of other systems out there. So again, opening your eyes to the opportunities, it might be staring in the face every morning.
Yeah, there's many factories that we work on that export, that dump actually so much heat that they can easily heat like a big city. For instance, if you take a good look at the amount of heat that Tata Steel is emitting in total, it kind of looks similar to the amount of heat that all the residential homes in the city of Amsterdam would require to stay warm. Knowing that, you may wonder why they even still continue subsidizing heat pumps for local use and not just put that big pipe there to bring the heat there. Next example, quite similar actually. So again, heat sharing. We had a biomass plant, and this one has to do with the regulations. So everybody constructs their installations in the end in order to make money. You have to run your business. And in some businesses, the business case depends on subsidies. Now, this plant was constructed to run optimally making use of the MAP subsidy, which was aimed at producing sustainable electricity only. This MAP subsidy scheme has a limited running time. So you construct the installation, you operate it, and after, you know that after some years the subsidy will be gone, and then, well, that may just be the end of the financial lifetime of the installation as it is. That is of course a pity, because you have a really good working biomass installation. So we looked at new ways to make money, and in this case they wanted to modify the operation to cogeneration operation, supplying heat to the nearby district heating grid. So they modified the installation from electricity production only to CHP, combined heat and power. What have we done there? We have modified both the boiler and the steam installation. A new steam turbine was installed suitable for extracting the maximum amount of heat and condensing only the minimum amount of steam in its own condenser. So we supply the steam to a nearby industrial user, and additional low temperature heat was extracted to increase the amount of heat that we take from the biofuel. Now, the total amount of energy that is exported has tripled if you take a look at the blue and green graph. That is of course very, very impressive. Other benefits of the upgrade that we did on the boiler was we made sure that the capacity was increased by about 10%, and even with the capacity increase that would generally result in less optimal combustion, we actually optimized the combustion and made sure that less carbon monoxide is emitted and also less nitrogen was emitted. And well, those of you involved or having seen a lot of political discussions on being allowed to build stuff in the Netherlands, we have big problems with NOx emissions in our nation. So this was a big advantage. Next example, waste boiler. This has to do with having waste streams, which is common in well, petrochemical sites, chemical sites, also tank terminals, and quite often these streams used to be flared. In this case, a client had quite a big stream of bisphenol amine, dirty chemical from their process, and as it was, they had only the option to flare that stream, resulting in a lot of emissions, in both heat and carbon dioxide to the atmosphere. And on top of that, flares often need natural gas as a support flame. So if you flare, you don't only flare the stream that you want to flare, but you also flare natural gas to make sure that you have a sustainable flame. What did we do there? We helped the client valorize the heat. With us being both a boiler and a burner OEM, we designed and constructed a new combustor that produced high pressure steam in parallel to the existing steam generator. So we did not only just construct a new self-working combustor with heat recovery, but we actually coupled it to the existing boiler to make sure that the high pressure steam was at the correct conditions to supply it to the existing steam turbine. The benefits of this solution: clean and efficient use of the waste stream, and further advantages, there's of course, with this being a 10 megawatt installation, a big reduction in the use of natural gas. And this of course reduces the carbon footprint of your plant. Similar example, also with a lot of waste streams. The previous example I showed was only about using one waste stream, but many of the more complex sites have many waste streams. This client had a total of 13 different waste streams, which had been divided over 5 boilers. Now, firing the waste streams on a boiler is in some ways similar to flaring them. Quite often these waste streams don't have a high heating value, so you need natural gas as a support fuel to make sure that you have a well-sustained flame, and you get nice, clean, complete combustion. What did we do? we engineered and constructed a new boiler system that combined all the fuels on one boiler. So we have a single combustion system that combusts 13 different waste streams on a single boiler. Now, this of course avoids the natural gas consumption on the other 4. Now we only need one stream of support natural gas, and we also upgraded the boiler to be able to cope with the new operating conditions that arise from burning a new combination of fuel. Benefits of this is clean and more efficient use of all the waste streams, reduction of the natural gas used as a support fuel, and then of course it results in a greatly reduced carbon footprint. Then my final example. This is of course quite a modern example. With ever increasing wind and solar power being installed, we get a very, very dynamic electricity market with electricity prices often dropping below the gas price or even becoming negative. Now when this of course gives you an opportunity to reduce your carbon footprint at times when there's an excess of electricity available. Another thing that clients want is they often want to have an additional backup for their steam or hot water systems in case their existing facility fails. What's the solution here? You can reduce your carbon footprint by using excess electricity on the grid to generate your heat. And the heat may then be hot water or also steam, even superheated steam. The benefit of this is you get low-cost steam at times, of course, when electricity prices are low, and you may even get paid to produce steam using the electricity. It gives you additional redundancy in your system. The integration in your steam system, or even integration with an existing boiler as a cheap option to keep supplying superheated steam. And superheating is still possible. Well, Martijn, this was my last example.
Okay.
I'd like to hand it to you.
Thank you. And Martijn has a penchant of touching stuff and adding big pieces of equipment or changing the piping. So I'm going to try and, this is the last option here, is to talk about ways you can enhance your efficiency, reduce your footprint by not even touching the facility, and that's through predictive maintenance. And this case I'm going to be talking about is a petrochemical client that many of you will know in the south of the Netherlands. And I just asked the client, give us your data, because you have some furnaces, they keep on going down. They're the bad actor. Let's see if we can get something from the data that you've been sitting on for so long. Because every time you go down, you are flaring, which is not good for the environment. And you get all these end products, all these waste products, half products during the unplanned shutdown. So what did we do? Well, we collected readings from existing instruments, so we didn't install new ones. We would have loved to have had some additional information, but we just looked at the existing ones. So this is pressure, this is flow, this is temperature, composition, acidity, flow. Again, we just looked at the existing signals that they had over the past years in their historian, and we also digitized their repair and cleaning logs. So sometimes we could get it straight out of the SAP system, sometimes we had to just take the manual logs and digitize them. But once we had that, we could put it into some very powerful data analytics tools. In this case, we used Aspen Tech's MTEL product, and we put some of our experts there. It's not just like, you put it in a black box and out comes the answer. But the answers certainly came, because once we started to analyze the data with these tools, all of a sudden it gave us much deeper insights into what was happening inside those quite complex furnaces. And the benefits were, first of all, the 3 cleaning exercises. We just couldn't understand why they were needed. We did not see an effect whether they were done or not done. And we analyzed it, all of a sudden the experts looked at each other and said, oh, of course that makes sense. So 3 cleaning exercises per furnace, less, so it's 2 days per furnace, less shutdown, more production revenues, and less activity at site. That's also a carbon footprint reduction right there. And on the other side, the insights definitely confirm some of the suspicions that we had, that there were correlations, but we never could put our, we couldn't positively say that we're there. But now, backed up with the data, we could positively say, if this is going to happen, so much later, a shutdown will happen. Allowing you just to put those preemptive measures, or even maybe avoid the unplanned downtime. So a very powerful testament to guys, if you are an existing asset owner and you're sitting on a historian full of data, don't just let it sit there, but let it be analyzed by a company who can assess that data and help you get these deeper insights. So, we've talked through 9 different options, and of course we could share a lot more. And I guess the big question is, of course, which one will work for you? Maybe already you've heard something and you say, this sounds familiar, maybe I have this problem. And then of course, you've already got your solution. But there are often so many more solutions out there, maybe staring you in the face, but you've never really looked at it because slowly they've crept in. And we would like to suggest that really the best thing is to really establish a baseline. Look at your whole facility, and not just your facility, but also just your surroundings. Who knows which light bulbs could go off there? And really also address the to-be situation. If your asset only has another 5 years of life cycle, of course your priorities and aspirations will be different than if you still want to operate that facility for another 15 or 20 years. Once you've done that, look for those opportunities. Just map them out diligently, every single one of them. The big and the small. Sometimes those small ones can really add up, and maybe those small ones fit in your budget, maybe those small ones fit in your scheduled downtime. So there's all kinds of reasons why you eventually need to select a few and prioritize those for the first pass through. And then the next phase is, you've got to have that mindset of actually doing it. This requires a totally different mindset. This is execute, execute, execute. So often the good ideas just pile up and we'll do it the next turnaround, or the next turnaround. So this is, again, the implementation is so critical. And the last one is, it's never a once-through effort. There's always more opportunities out there. It's a roadmap, basically, a journey to decarbonize your existing asset. So this road mapping is certainly simply, most probably the best place to start. So if you just, staying competitive in the greening world, that was the title of this presentation. And I hope we shared, that there's lots of opportunities, best discovered if you start off with a very thorough road mapping. Don't just go for that first big shiny thing out there that could blow your budget, not fit in your turnaround window, and all kinds of other, not fit in your existing footprint. So really go through that effort of doing the whole master planning. Look at those efficiency opportunities, efficiency upgrades. We shared a few here on the control systems, but also turbine reblading, the deaerator example, adding more insulation, just all kinds of different ways that you can increase the efficiency of your asset. We also talked about the waste valorization. It could simply be heat exchange, but it could also be taking that remaining calorific value and turning it into steam and turning it into something useful. It could also be electrification. We talked about the e-boiler, but it could also be changing out your drives from steam turbines to electrical drives. It could be electrical heaters and mechanical vapor recompression. There's all kinds of electrification options out there for you. Of course, powered by green electricity. We didn't touch on this one, fugitive emissions. There's still a lot of facilities out there that are leaking. Maybe a little less in the Netherlands, but there's still, every time we go to new facilities, we're surprised at how much leakage there still is. And good flames management, but also taking care of the seals, especially around, if you have tank farms, great opportunities to avoid those emissions, especially of course if they're methane. They should be tackled. It's it's not a coincidence that the COP26 methane emissions was really noted as one thing that we need to all collectively stop. Also another topic we didn't touch on, but of course it's very effective to still capture the pollutants before they leave the stack, whether it's CO2 or NOx. And we also shared with you about the predictive maintenance opportunities. So this is kind of like a little recap of the categories as we see them in Stork and how they, the ones we always look for as the low-hanging fruit as we're assessing clients. So to really wrap it up, the recap that we promised, I trust you agree that there are lots of ways to decarbonize existing, especially ever-changing facilities. Because again, it's not a bad design, but it's through the changes over time that these inefficiencies have crept in. And they can really help you decarbonize and also, quite often, drive down your footprint. And the key is selecting the right ones, the ones that fit your budget, your turnaround schedule, that fit your the footprint that you have available to make changes. And the art is, of course, knowing what's good for your facility. And again, it could be the small ones. Don't underestimate the effect of the small ones, and also how big sometimes. I mean, the tripling sometimes possible if you just take a real good look at these. And as you're taking that step back to really look at your whole facility, just make certain that you really get a multi-discipline crew in there. Not just people who love molecules, not people who love certain pieces of equipment, rotating people, also the process people, the electrical people, get them all involved. The control systems people, get them involved, because you don't upfront know where the biggest benefits will be for you. And I believe that brings us to question time. How are we doing on time, actually?
Much question, but I would like to discuss. It looks like you can take over a whole plant if you want, as Stork, but I assume your customers won't like that. Can you tell me what triggered those customers? You've mentioned already, I think 13 examples of low-hanging fruit, but they had to start somewhere. And what triggered them to take the first step? Because we see in the industry that first step is, well, they know they have to take it, and you showed the 4-stage plan, but they never come to stage 4.
Yeah. No, I think this is a little magic maybe that's happened in the last 150 years that Stork has been at site. So we build up a relationship just doing manual maintenance, and we come across things and we talk about things. And then I think the growing awareness, the public awareness that this is something we have to do, and that just stimulates more discussion. Yeah. So and it becomes with awareness. There's so many of these topics that if you take a look back, we sometimes wonder, why didn't the client tackle this earlier? And it's simply because you become blind. And I think it's through these discussions from people with a different background. We're pure O&M, and they are pure asset owners. And I think it's the dialogue. And I think events like these surface even more and hopefully make people curious. Yeah. Am I blind for something out there? And I think that's the exciting part, because that's where the magic starts. It starts by awareness, and once the awareness is there, dialogue, and the solutions will come.
And there should be something for both parties, I think. I think there should be something in for both parties, so yeah. Your benefits are clear, but their benefits as well, I think. So how do we share those benefits?
Yeah, well, we believe that if we do a good job and the client can get more revenues, less downtime and less OPEX, then he must probably keep us at site for another 10 years, and that's basically where our core business is. So, yeah.
Okay.
Any other questions, maybe from the audience here? Yeah?
I have a question. So, can you hear me like this?
Yeah.
Thanks a lot for great examples that you gave to us to decarbonize existing assets. But I was wondering, one option that you did not talk about is moving from natural gas firing to burning hydrogen.
Okay. Yeah, that's true.
Can you maybe
I'll repeat. So basically the question is, lots of examples, but nothing about exchanging the way that you fire equipment. So yes, with waste, but the word hydrogen wasn't mentioned. So maybe, do you want to take this one?
Yeah. Well, this of course touches to a large degree the example that I showed with the combustion installation combusting like 13 different waste streams. Many of these waste streams were actually hydrogen, or to a large degree contained hydrogen. Now, we are a boiler manufacturer that focuses on different fuels, let's put it that way. So there's many parties in the market that can sell you like a regular diesel or natural gas burner. We focus on burning difficult mixtures, complex fuels, different stuff, low emission requirements, and we basically combust anything that is liquid, gaseous, or powder. Hydrogen is of course a gas. It combusts quite easily, and we have many installations in operation which combust hydrogen. To us, it is not that special to do so. We should actually tell more about it.
Yeah, maybe we should update the PowerPoint, say
Yeah.
hydrogen as well. And maybe another thing is we are working on currently our burners are on typically on air, and one of the things we're developing is a burner for pure hydrogen but also pure air. And if you put that in a boiler, you basically get a stackless boiler. So that's just one of the things we're working on from an innovation point of view, and we are running our tests
Now?
now. Yeah,
Yeah, it's
I think this is
oxygen combustion.
perfect example
Okay.
to end this session. Martijn Glas, Martijn Hindal, thank you very much for this, I think great presentation and great examples of how we can gather the low-hanging fruit, and I invite you all to go to the other side.